Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. So if you have been liking the kinds of videos that I'm making, you should consider subscribing to the channel. In this particular video, we are going to talk about what are Kubernetes controllers and operators, what are the use cases in which we would want to use controllers, and what are the use cases where we would actually want to use or want to write operators. So before going into those terminologies, let me very briefly talk about Kubernetes Controller Manager. So in one of the previous videos, we have actually talked about Kubernetes Controller Manager, and we know that Kubernetes Controller Manager is a component or core component of Kubernetes that actually consists of a lot of separate controllers. So for example, let's say if we talk about controller manager, let's assume this is controller manager. Controller manager is actually consisting a lot of small controllers, and that are actually responsible to do some things inside Kubernetes cluster. We are going to define controllers in a bit, but I just wanted to set context on what exactly controller manager consists. So now that we have this thing clear that controller manager actually has some controllers for different kinds of things. Now let's define controller. So controller is let's say controller is a program that is running on your Kubernetes cluster that is responsible to do some tasks. Very simply, we can say that that is just responsible to do some tasks. So for example, if we talk about a specific controller inside controller manager, that is deployment controller. So let's talk about deployment controller. So deployment controller is actually responsible to make sure that n number of or specified number of replicas of a specific pod is always running. So for example, let's say we want to run 3 replicas of a specific pod, and we use deployment controller to actually manage that. So we create a deployment resource, and this deployment resource actually runs these particular pod. Now again, as I defined controllers, deployment controller is again just a program inside controller manager that actually makes sure that the specified number of replicas of a specific pod is running all the time. So for example, if I specify 3 here, in this particular case, it means deployment controller will make sure that 3 replicas of this particular pod is always running. Now let's assume due to certain reasons this particular pod was deleted because of certain reasons. Now deployment controller would be able to figure out that user has specified the replica count to be 3, but the actual replicas that are running on the system is 2. So in that case, deployment controller is actually going to spin up a new pod just to make sure that the number that is specified in the deployment controller actually matches with the actual replicas that are there on the system. So now there are two things that we are talking about. One is the number that user has specified, and another is the actual number that is running on the cluster. So now if I try to enhance the definition of controller, it would be controller is an application that is running on your Kubernetes cluster that actually tries to match the system's state or the current state. This is current state, and the reason is this is how the system looks like as of now. So this is current state. So, and this is the expected state or the user defined state. So if we try to modify or improve the definition of controller once again, it would be controllers are programs that are running on your Kubernetes cluster, and they are consistently trying to match the current state with the expected state, or the current state with the specified state. So this is I would say, a good definition of controller. And we know that there are n number of controllers that are already running inside manager. So for example, when we create a service, an endpoint resource gets created automatically, and that happens because there is a service controller running inside Kubernetes controller manager. So let's just go ahead and try to look into all these controllers that are there in the Kubernetes controller manager. So we can see this is Kubernetes source code, Kubernetes repo source code, and inside package and controller we can see we have cron job, daemon, deployment, disruption, endpoint slice. So all these controllers are already running inside cube controller manager. And this is how controller manager is actually able to make sure that system is in the state that user wants it to be in. So yeah, this is very basic definition of controllers. Now, to actually reconcile or make sure that the current state of the cluster is in line with the specified state of the cluster, this controller will have to query the resources that it is looking for. So for example, in case of deployment controller, so let's take an example about deployment controller. So in this particular case, deployment controller is managing pods. So this particular deployment controller would actually poll or query all the pods that match the definition that has been specified in the deployment. So for example, if I say there should be app equals to front end, there should be 3 replicas of pod that has this particular label. So in that case deployment controller would poll or query the Kubernetes API server to actually figure out how many pods are running with this particular label. So let's say we have 3 pods running. In that particular case, this controller, let's say this controller is going to talk to the API server, and API server is going to say that we have 3 pods with this particular label. In that case, this particular controller is not actually going to do anything. But let's say again, as we discussed, if this particular pod was deleted due to certain reasons and deployment controller asks Kubernetes API server again, how many pods are there with this particular label, if Kubernetes API server says that there are 2 pods, in that case, to match the current state of the cluster with specified state, deployment controller is going to create another pod with the same label. So this is what actually happens internally when we deploy a controller. So controller actually queries for the resources that it is interested in, and then it actually matches or reconciles the expected state or the current state of the cluster with the expected state. Now, if I say current state of the cluster, I mean the cluster is, for example, let's say I'm saying there should always be a namespace with name ABC. So this is my expected state. But if a namespace is present with name ABC, this would be current state of the cluster. Current state would be either if this particular namespace is present or not, and expected state is this particular namespace should be present. So we can write a controller to actually manage this. Now let's go ahead and talk about a very simple use case of controllers. So now all these controllers that are there, we can see here inside controller module, we can see all these controllers are just called controllers. But if we want to write our own controller for native resources, for example, let's say like this particular example, I want to make sure that there is always one namespace with the name ABC. In this particular case, we will have to write our own controller that is going to query all the namespaces, and if there is not a namespace named ABC, that controller is going to create that namespace. So this particular controller is called custom controller because this is not shipped with Kubernetes. We wrote our own logic and then deployed it on Kubernetes. Let's go ahead and try to look into another more useful use case for controllers. So for example, we know that let's say this is our Kubernetes cluster, and in this particular Kubernetes cluster we have some namespaces. This is namespace 1, this is namespace 2, and this is namespace 3. Now we know that secrets are namespace resources. So if I just go ahead and try to create a secret in this particular namespace named S1, but if I want to use this particular secret, let's name it NS1, NS2, and NS3. So if I want to use this particular secret on any other namespace, we will have to manually create this particular secret on these namespaces. So we will have to create this particular secret on these namespaces manually. To simplify this particular process, what we can do is we can deploy a custom controller, let's say, and we can name it, let's say, secret controller. And what this secret controller is going to do is this secret controller would actually listen for secret resources, and then it would sync that secret resource on rest of the namespaces. So for example, this particular, if we talk about this particular controller, is actually going to query. We have specified, we have written the logic that if any secret is created on the Kubernetes cluster, that secret should be replicated or should be created on all the other namespaces as well. So this secret is actually going to query, let's say this is API server. So this controller is going to query the API server to consistently check if any secret is created, and as soon as a secret is created, this controller would get that secret detail, and then that once a secret is created, this controller would also be able to figure out which particular namespace that secret is created in by looking at the secret spec, not secret spec but secret metadata. And after that, this particular controller is actually going to, for example, let's say this secret was created in NS1, this controller is going to create that secret on NS2 and NS3 as well. So we can see here we have removed this manual creation of the secret on different namespaces. So this is where custom controllers come into picture. So in other words, we can say that custom controllers are controllers that work with Kubernetes native resources. Now let's just go ahead and try to talk about what exactly are operators. So before discussing about the definition of operator, let's talk about if we want to run a distributed database on Kubernetes, how are we going to do that? So let's say we are running a distributed database with these many nodes, and this particular node is leader node, and this entire thing is running on Kubernetes. So this is our K8s cluster. Now, and they are obviously talking to each other using some network connection methods. Now let's assume I want to add another replica. So let's say this is leader and these two are followers. Now let's assume I want to add another follower to this particular cluster, or another secondary node onto this particular cluster. So let's assume I want to add this particular follower F3 onto this particular distributed database cluster. I'm not talking about Kubernetes cluster. I'm talking about whatever distributed database you are running on this particular Kubernetes cluster. So if you try to add a follower onto this particular database cluster, distributed database cluster, there are some steps that you will have to perform. For example, you will have to make sure that all the data that is there on the leader node is replicated onto this follower node, so that if any client talks to this particular follower, they would be able to get up-to-date data that is there on the leader node. So this is one thing. Now to achieve this, what database administrator will have to do is they will have to take snapshot of this particular leader node. So first step would be taking snapshot of the leader node. Second step would be to copy that snapshot onto the follower, copy that to F3. Now the problem is, if we try to take the snapshot of the leader node, we will have to make sure that we are taking application consistent snapshot. And to take application consistent snapshot, we will have to flush all the data. Again, I think that should be part of, I will be discussing about this when I'm discussing about distributed systems. But to actually take application consistent backups, we will have to write every replication log to the disk, and that makes the leader node unavailable for some time. So we don't actually want that. We cannot have that. We cannot have leader node unavailable. So what we will have to do in that case is we will have to make leader application consistent for some time partially, and then we will take, let's say, snapshot at time X, and after snapshot is taken, we would copy that snapshot to this follower, and let's say we will then try to figure out the difference between X and X3, because we took the snapshot at time X, and now let's say the time is X plus 3. So we will have to figure out the changes that were done between X and X3, and then copy those differences to F3. So all these things would be done, or would be required to be done by this database administrator. So for example, manually someone will have to do all these things that we just discussed about. So but to actually resolve this particular issue, or to automate this, we can actually use Kubernetes operator, and that is where the name operator comes into picture. Another use case, if we talk about, let's say we are running distributed database on Kubernetes, and this particular leader goes down. So we will have to make a specific follower the leader of that particular distributed database cluster. So in that case, again, there are a lot of manual things that are involved. For example, we will have to make sure that if the old leader gets ready, he doesn't think that he is leader again, and things like that. So all these things, all this manual logic, business logic can be written as part of operator, and that is where an operator comes into picture. So what we can do is, so for example, let's say we have 3 node cluster, and again all these clusters are, let's say, talking to each other. Now this is leader node, this is F1, this is F2. What we can do is we can actually create operators to make sure that if we want to add a node to this particular cluster, what we can do is we can create a resource on Kubernetes cluster. For example, if we talk about custom controllers, in that case we queried the Kubernetes native resources. But in case of operators, we are going to introduce custom resources, and again we have already talked about custom resources. So if you're not very familiar about them, maybe you should check out that video. So let's say I have introduced a CR named node. Now as soon as I create this particular node resource, my operator, this is the operator, let's say this is the operator that I have deployed on Kubernetes cluster, and it is named, let's say this database is VDB, and this operator is going to be named VDB operator. Now as soon as I create a node resource, this VDB operator is actually going to listen, or is actually going to query the API server. This is, let's say, API server, and this operator is actually consistently querying API server to check if there is any node resource added, and as soon as node resource is added, this VDB operator is going to do all that manual thing for you. For example, adding a node and making sure that all the data that is there on the leader node has been successfully copied to this particular follower node. So this is, I think I'm making sense, and I'm able to make you understand what is the use case of operator and in which particular case you should write an operator. So again, operator is another program, a code that you write and get it deployed on your Kubernetes cluster that actually listens for custom resources and then does some expected things. So for example, there were three nodes on your distributed database cluster. As soon as you created another node resource, it simply means that now the expected state is there should be four nodes on your Kubernetes cluster. So expected would be four nodes, and your VDB operator would be able to figure out that there are only three nodes on your cluster as of now, on your database cluster as of now. So this is current state and this is expected state, and what operator is going to do is operator is going to make sure that the current state actually matches the expected state. So in that case, it is going to add another node and then it is going to do all the manual things that we discussed about by its own. And that is the beauty of operators. So for example, it is we are going to write logic. When we write operators, custom operators, we are going to write logic that create a node, take application consistent backup or snapshot of leader node, copy that to the follower, and then copy the changes that are done since we took the snapshot to, and then copy that to F3, and then F3 would be caught up, and we can update the status of this node resource that it has been added successfully. So yeah, I mean, this was pretty much it that I wanted to discuss about controllers and operators. If you have any questions, I would be happy to answer them on comment section. You can follow me on Twitter as well. And yeah, if you did not understand something, just let me know. I would be happy to answer them for you. Another thing that I would like to talk about is very briefly, nothing is happening by its own. When I say controller, when I say operators, every logic that we just discussed about, we are writing that logic. It's just once we have written that logic, any custom resource that is going to be added, this particular operator would poll that, and then actually going to do all this heavy lifting that we discussed about operators would do, or administrators would do if we didn't have operators. So yeah, this was pretty much it. I'll see you in the next one. Thank you.